Hello, welcome back to my YouTube channel. It's Dr. Jeremiah here again, and today I'll be showing you how to solve calculation questions under friction, including the dreaded friction on an inclined plane. So let's just get started with the video. Make sure you watch to the end so you don't miss out on important steps. I'll be using to solve them. I'll be dropping some shortcuts. I'll be dropping the formulas. I'll be explaining the concept. Usually, why students fail questions under friction on inclined plane, they don't understand the concept of how it works. So today I'll be showing you the concept and everything about friction. So let's get started with the video. So the first thing you need to know about friction is that friction opposes motion. It opposes motion. That's the first thing you need to know. That, for instance, if I'm moving in the x direction, or let's say I'm moving in this direction, friction will be backward. So frictional force, the motion is the body is moving towards you, while the frictional force is along my direction. So that's what friction just means. It's not a big deal. Now let's just get started with it, because today is for calculation and not for explanation. So just go learn some basic stuff about friction. So what do you need to know about friction? The first thing, we're going to be starting with friction on an horizontal surface. Friction on an horizontal surface. Now, take for instance, just follow me. Make sure you have gotten your note with you. So take for instance, we have a mass. Let's use a block of mass 10 kg. So this is a block of mass 10 kg on an horizontal surface. So this is the horizontal surface. I told you we're going to start with friction on an horizontal surface before we go to friction on an inclined surface. Now, this is the block. This is the block of mass. Now, for instance, if I pull this block, just follow me. If I pull this block along this horizontal surface, I will call this P. That's pulling force. I'm showing you why students find this thing problematic. It's not a difficult thing. Now, this pulling force, I told you that friction opposes motion. So if the body is moving in this direction, I pull it, for instance, Dr. Jeremiah pulls this 10 kg block in this direction, it surely means that the block is moving here. Now, if it is moving in this direction, where will your force be? You already know from my definition that force. Your frictional force will be in this direction. So I'm going to label frictional force as FR. So this is frictional force. I hope you are following. So we have been able to resolve two forces now. We have the pulling force, which is to pull the block, and the frictional force opposing the pulling force. This is very important when you are solving questions, so please take note of it. Now, another important thing to take note of is that this block his weight is acting downwards. I know from physics that your weight equals to mg. So you already have 10 times 10. Don't use it as 10, usually 9.8. So 10, just approximate it as 10. You have 100 newtons. Now, tension. These forces in the horizontal and forces in the vertical. So the forces in the vertical is weight and tension. Tension opposes weight. Tension, or we call it reaction force, opposes weight. So let's better call it reaction force here. We have reaction. So reaction is opposite weight. For a body moving in an horizontal surface, reaction force is opposite weight. And usually you can say reaction equals to weight. So reaction equals to mg. For an horizontal surface. So these are the resolve forces on an horizontal surface. Hope you are getting it. So this is the first thing to know about resolution of forces on an horizontal surface. Now, what you need to take note of next is the net force. Now, if you look at this frictional force and pulling force, there's a net force, because if I drag this body along this surface, this frictional force is moving in this direction. So what is the net force? The net force just tells us that let me use this guy. The net force just tells us that net force, let's call it F net equals to what direction is this body moving? Is it moving in this direction or is it static? So if I pull this body along this direction and it moves, so I'm going to get P minus FR. This is the formula I'm going to be using to calculate for net force anytime, any day. P minus FR. That's pulling force minus frictional force. Because if I pull this body along this surface, it's going to move in this direction. So pulling force is surely greater than frictional force. But please take note, there are two kinds of friction. We have the static friction and the kinetic friction or dynamic friction. And for the dynamic friction or kinetic friction, pulling force is surely greater than frictional force. Yes, except the body is coming to rest. So pulling force is greater than frictional force. So I'm going to have, maybe for instance, pulling force there is 10 and frictional force is 7. That's why the body can move. You get? But for static friction, please take note that the body is not moving. The body is just about to move. You look at the definition very well from the textbook. I told you guys to go check it out. So that it's going to say that when the body is about to move, you have static friction and not kinetic friction. Please take note. It's a very popular Jamb question. So when the body is about to move, this pulling force is trying to overcome the frictional force. It's trying to overcome the frictional force. And take for instance, we have 10 Newton as pulling force, trying to overcome 10 Newton also frictional force. So this for static friction, the net force is 0. For static friction, the net force is 0. Please take note, for static friction, the net force is 0 because the body is not yet moving. It's just about to move. So static friction is the force that must be overcome before a body can begin to move. So the net force is 0 Newton for static friction. Please take note. Now, another thing you need to take note about net force is that F net force, equals to mass times acceleration. Please take note. Many students find this confusing because sometimes they'll give you net force, or they'll not give you net force, rather they'll give you mass. They'll say look for frictional force, and they gave you pulling force. What do? You look for net force, then you use this formula and look for your pulling force or frictional force, as the case may be. Sometimes there's a question that WAEC asks. I can't remember the year. They asked the question. They just gave you mass and acceleration, they look for net force, and they gave you pulling force. They gave you weight and reaction. They didn't give frictional force, something like that. And then you just start crying, yo. What are you supposed to do? Just times mass and acceleration. These kind of Jamb questions nowadays, you're just asking plain question, but you don't know the simple question. So please take note that net force equals to pulling force and frictional force, and also equals to mass times acceleration. So we have two formulas for calculating net force. What do we get? Now let me tell you some things about frictional force, because it's going to be very important as we progress. One of the laws of friction states that let me use this guy. One of the laws of friction states that frictional force is directly proportional to normal reaction. It's directly proportional to reaction. Now, this means that so this FR, I just write a small letter R. Hope you are following. So this means that FR is directly proportional to reaction. Now, if I introduce my constant, now we put this constant in mathematics. So if I introduce my constant, this is directly proportional. So I'm going to have KR. But in physics, I don't just use K. The constant is specific. So this constant that you have here, U, not actually U, is mu. Yeah, but people in Nigeria pronounce it as U. So mu, or whatsoever you want to pronounce it as, just know that this is the symbol. So this symbol is known as the coefficient of friction. I hope you are getting what I'm saying. So this is the coefficient of friction. This guy, let me write it here in case you didn't see it. So it's known as the coefficient of friction. So you see, they want you to look for coefficient of friction. This is just the formula to use. F equals to coefficient of friction times reaction. That's just all you need to know. Then another simple relation that you need to take note of is that if I make coefficient of friction, let's use this place. So you make sure you're going to have U equals to FR. That's this frictional force. Please just try to differentiate it. Just know it, you get. So frictional force over reaction, normal reaction. Now, also this guy equals to tan theta. When you're solving question on the time, is something very strange thing. They don't need to derive anything. Just know that every time coefficient of friction equals to tan theta, you are good to go. If you are in the hall, they say look for theta. Just do theta equals to tan inverse of coefficient of friction. You should know all these trigonometry calculations. So hope you get it. So that's just all you need to know about friction. We're going to get into solving questions right away. Alright, so let's move. The first question should be shown on your screen now. I will read from here. It should show on your screen. Just read from your screen and follow me. Just a block of wood of mass 5 kg is pulled on a platform by a force of 40 Newton as illustrated in the diagram. Let me go into the diagram. So there's no need to go into the diagram. We can represent it by ourselves. So the question says, read the question. It says a block of wood of mass 5 kg. Write your 5 kg here. Is pulled on a platform by a force of 40 Newton. So it means the pulling force P equals to 40 Newtons. Remember our representation earlier. If the frictional force experienced by the block is 12 Newton, you know that frictional force acts to this direction. You're going to have Fr equals to 12 Newtons. You say if the frictional force is 12 Newton, calculate the magnitude of the acceleration of the block. I'll say something like this. You know, say, why am I calculating acceleration? Also, some people don't know that net force, that formula of net force I gave to you guys earlier. Remember that what's the simple thing to do now? Your net force equals to pulling force minus frictional force, and your net force equals to mass times acceleration, which equals to pulling force minus frictional force. Now, what is pulling force? 40 Newtons, and what is frictional force? 12 Newtons. So you have mass times acceleration. You can see put my net force down to be very fast. 40 minus 12, we are going to get 28 Newtons. Now mass times acceleration, we divide both sides. What are we looking for again? Acceleration. So if we divide both sides by mass, we're going to get acceleration equals to 28 divided, what is the mass? Class 5 Newtons. Hope you followed. So 28 divided by 5 will give you what? Just quickly point that 28 divided by 5 will give you 5.6 Newton. That should be option B on your screen. So hope you get the concept. Very simple stuff. Just simple. Just know how to draw the diagram. Okay, pulling force to direction, frictional force is to the direction. Then net force equals to pulling force minus frictional force. Then net force equals to mass acceleration, as you all know. You can decide to just look for net force first. Then now say F equals to MA and do your division. But those are waste of time. This is a Jamb, writing a Jamb exam that is timed. You don't have the whole time, so you have to answer it very fast. So for UTME, every exam you're going to write in your life is timed. So know how to solve questions very fast. So let's quickly move to the next question. Question 2 says a load is pulled at a uniform speed along a horizontal floor at 45 degrees to the floor. Okay, let's quickly represent the diagram now. It says a load. Remember that we must represent the diagram. A load is pulled at a uniform speed along a horizontal surface by a rope at 45 degrees to the floor. So this is the rope. Yeah, pulling this guy. So it's this is the rope. I probably put this question to show you something. So this is the rope. Now this is the horizontal. Normally this is where the pulling force should be, you know. So it said that the rope is 45 degrees to the floor. So this is the floor. This is the horizontal. So it's 45 degrees. So this is the rope. This is the rope. So what's the next thing? We're going to resolve it. If the force on the rope is 1,500 Newton, so the force on this rope, like this, is 1,500 Newton. The force. What is the frictional force on the load? What is the frictional force on the load? That's the frictional force in this direction. What's the frictional force? Remember our horizontal surface, and this is the load. Now, this question is just simple. I was telling you guys about static friction. So let me start from there. I was telling you guys about static friction, that frictional force equals to pulling force in static friction. And this tells you that the question said at a uniform speed. You read the question again. It says at a uniform speed. Just take note that whenever you see uniform speed anywhere, that acceleration is 0, and also static friction. So that's static friction. Remember I told you earlier that for static friction there is no net movement. So it means acceleration is 0. That's what we mean by uniform speed or uniform velocity. So acceleration is 0. That goes to tell you that net force or F net, anyone want to write it, equals to pulling force minus frictional force, which gives you 0. So if you have pulling force minus frictional force equals to 0, this means that pulling force equals to frictional force. If you bring frictional force to the other side. Hope you get. So when we have static friction, pulling force equals to frictional force. Please take note. Now, with this being said, how do we now solve this question over here? Now, I was telling you guys that when you're not okay, what we get here now is our frictional force, because it's static friction, because there's acceleration equals to 0, uniform speed, uniform velocity, and all that. Whenever you see body about to move, uniform speed, just know that it's static friction. So now, how do we resolve this guy? Please take note that your forces on an horizontal surface must always be to the horizontal. So we're going to resolve this, the force of this rope, to the horizontal. We're going to be getting X value here now, X Newton. We're going to be resolving this force to the horizontal direction. And how do you resolve forces to the horizontal direction? Remember your resolution of vectors, component vectors. That forces to the horizontal are going to do, so let's say R, okay, let's say P, our value pulling force, equals to R cos theta. R cos theta. Why to the vertical you have P equals to R sin theta? Now let me quickly just tell you a simple trick. Oh, I've removed that diagram. So imagine this was weight. Sorry, this is weight. Weight is downward. Imagine this reaction. And the reaction was put like this, inclined to this guy. You must resolve it to the vertical. You must resolve the weight to the vertical. Imagine it's inclined to this horizontal. You must resolve it. So weight and reaction must be resolved to the vertical. But pulling force and frictional force must be resolved to the horizontal. So it cannot be like this. You get? So say it's pulled at 45 degrees. Just resolve it to the horizontal. And to resolve the horizontal, we use P equals to R cos theta. Now if you do that, you're going to get what's the value again? 1,500 Newton times cos 45 degree. So that gives you 1,500 times, what's the value of cos 45 degree in trig ratio? They have 1/√2. Now if you do 1/√2, just press on your calculator. Let's go. 1/√2. Just punch it. So that gives you, sorry, 1,500 times 1/√2. I think 1/√2 should be 0 point something, 0.7 something. So that gives you 10, yeah. So our answer is, we write it now, answer equals to 1060.6 newtons. I think that should be option D. Option D. So you have gotten our answer, 1061 newton. So that's the value for the pulling force. And remember that pulling force equals to frictional force in static friction. So the value of the frictional force is 1061 Newton. So I'll be giving you an assignment at the end of this video to watch to that point to test yourself. Alright, so let's quickly just go to friction on an inclined plane. Now, the first you need to take note of is the diagram. Please follow carefully, because many students ask me, I find it difficult to understand how it works and all that. So it's from this diagram I'll be drawing now, this explanation, I'll give you a breakdown that I'm going to use to solve any question. We're going to solve some questions, but this is very important. Okay, let's take for instance, this is an inclined plane. This is an inclined plane, and we have a block of mass, let's say 10 kg. Then remember I told you under evolution of forces for horizontal surface that we have a force acting from here. Yeah, a force. It's called the normal reaction. You can call it the normal force. So we have normal reaction acting upwards, and also from this block we have a weight acting downwards like this. We have a weight acting from this point. Okay, let's draw it from this point. So we have a weight acting downwards like this. So this is called weight. So these are the first two things you need to know about when you're resolving forces in the vertical: reaction and weight. Weight acts downward, reaction acts upward. Now what's the next thing we need to know now? This inclined plane has an angle. That's why it's called an inclined plane, because it's inclined at an angle. Now see, from here, this is what most students find confusing. Now this weight, we're not going to use to solve questions, because if we see, if you make this thing a straight line, let's try to give some broken lines. We are going to have an angle here. We're going to have an angle here. Remember I said during our friction on an horizontal surface that when you have an angle, when you have something inclined at an angle, you don't use it. You cannot just use weight like this. Now you have to resolve it either to the vertical or to the horizontal. So let's label here as X and here as Y. Now this is the resolution of weight. Let me quickly say this. We have the resolution of weight along the plane and down to the vertical, perpendicular to the plane. So this is along the plane. So what we're going to get here is along the plane because it's horizontal. While what we are going to be getting here now is down the plane. It's one corresponding to reaction here. You get? Because we have to resolve it. Now, what we're going to do next now? Remember from your angles you have what called trig ratio. So we have Now, if you want to resolve this guy, this is opposite, this is adjacent, and this is hypotenuse. Now when the angle is facing is known as opposite from trig ratios. Now, opposite over hypotenuse, this is where weight is. Opposite over hypotenuse, we're going to have opposite over hypotenuse is what? Sine. This is cos and this is tan. So we have opposite over hypotenuse. This is the hypotenuse, this is the straight line. So this is the hypotenuse. So opposite over hypotenuse. So we're going to have sine here, sine theta, W sine theta along this plane. How is it sine theta? Now we have, I told you opposite over hypotenuse. So we have sine theta equals, just follow me. Sine theta equals to x opposite over hypotenuse. What's the hypotenuse? The weight. Now if you cross multiply, if you make this over 1, you're going to get x equals to W sine theta. Shikena. So you see, this is W sine theta. Now for this place, we do same thing. Cos theta, we have this adjacent. So we have cos theta, just follow me, equals to y over, what do you have here? Weight. Weight is this place. Yeah, this is weight. So I'm going to have y equals to W cos theta. So it means this place we have W cos theta. What does this tell you? That along the plane or down the plane we have W sine theta. Hope you are following. While across this plane, that's the magnitude of the weight balancing the reaction force, it's W cos theta. That brings us to this important derivation. So now that we know that we have W cos theta here and W sin theta here, what do we do next? So the resolution of the forces in the vertical is what? R equals to W cos theta. So we're going to label it as equation 1. Yeah. So W cos theta, that's equation 1. That's the forces acting in the vertical, perpendicular to the plane. So this guy is called perpendicular to the plane. Why? This W cos theta is called perpendicular to the plane because you see, this is perpendicular to the inclined plane. So it's perpendicular to the inclined plane. Now we say along the plane and perpendicular to the plane. What is the resolution of weight? Please know this basic thing. In my own Jamb, they didn't ask me to even solve calculations. They just told me along the plane what's the resolution of weight. So please take note. I think I said this in one of my videos. Yeah, on the important topics to take note of in physics. Go and watch that video. I'll place it in the description. Yeah, I said that question word for word. It was my Jamb question. So let's continue. So we have W sin theta. Now along the plane, what do we have? So along the plane, we have W sin theta already. Now if this block is at rest and maybe sliding downwards. So let me just even say this. The proposed motion for a body on an inclined plane is downwards. Why? It's imagine that the block should slide downwards. With the way the block is placed, with the way the inclined plane is structured, the block will also slide downwards. So the proposed motion is downwards, except otherwise stated. Yeah, we'll solve some questions. Now, so if the proposed motion is downwards, what does that tell you? It tells you that frictional force is upwards. I said this at the beginning of this video. Please go back. That friction opposes relative motion. So frictional force is upward. So what does that tell you? That the resolution of forces along this plane is going to be net force, let's call it F net, equals to where is the motion going? Where is the body going? The body is going downwards. So we're going to have W sin theta minus frictional force. So that we can call this equation 2. And if the body is at rest, if this body is at rest now, we can say net force is 0. I explained this in the previous video. Sorry, in the previous solving on horizontal surface. So we're going to have W sin theta equals to frictional force. Now, if the body is at rest, So this is equation 1 and equation 2. Now, let's just call this equation 3. So remember that frictional force equals to mu how? That's coefficient of friction times reaction, and this is frictional force. So this is coefficient of friction. Now there's something we can do here because when we use it for your solving. Remember that R equals to W cos theta. So we can replace here. We can replace R here now with W cos theta. You save your time in the hall. You can call this equation 4. You see, I've given you simple derivation which means to solve any question on inclined plane. And also lastly, note that I think I said this, net force in the previous video equals to mass times acceleration. So they say, in case they say find the acceleration of the body, all you just need to do is A equals to, for instance now, I'm find acceleration of the body here. What will I do? Let's go here. MA equals to W sin theta. Hope you are following. Just follow. Equals to FR. So I'm going to have A equals to W sin theta minus FR divided by mass. So very simple. So that's just the way this inclined plane works. With this, we are going to solve questions now. Just so that this is perpendicular to the plane and this is parallel to the plane. That's along the plane, perpendicular to the plane. So I think with this we are good to go. Now let's solve the first question for today. Now the first question is showing on your screen. It says a block of mass 50 kg slides down a plane inclined at an angle of 30 degrees to the horizontal. If the coefficient of friction is 0.4, calculate the frictional force between the two surfaces. Now, we already know our formulas as let's first write the parameters. I think there's a video I did on how to become a god in physics. I told you that when you're solving questions, always start with the parameters. So please go and watch that video so that you understand how we solve questions in physics. So the first thing now, we have mass equals to 50 kg and the angle of the inclined plane is 30 degrees. Then it says if the coefficient of friction is 0.4, calculate the frictional force. Coefficient of friction mu equals to 0.4. Then we have G equals to 10 meter per second squared. Now the body say the question says the block slides down the plane. So draw the diagram. We're going to have, let's just draw a simple diagram. We're going to have I hope you can see it clearly. So we have slides down. So the body is moving downwards. So it means normally we have our W sin theta here. Since the body is sliding downward, it means frictional force is acting upwards. Simple thing, it opposes motion. Now, since it slides down, the reason I drew this diagram is that is so we know that it's sliding downwards or upwards. If it's sliding upwards, frictional force is acting here, and this guy is still here. This guy is always here. W sin theta is always here, and W cos theta is always here. Yeah. So since this guy is acting downwards, it means we have net force that's along the plane. We have F net equals to W sin theta minus frictional force. Then what we will look for? Looking for frictional force, okay? And we know that the resolution perpendicular to the plane is R equals to W cos theta. We have already done this. And also, they now say look for frictional force. We're looking for frictional force. Let's write it out. Frictional force. Now, if you look at this very well, we don't know what is net force because we're not giving acceleration in this question. Please take note. Acceleration is not equal to G here. Please take note. It's not equal to G. So we don't know acceleration. So it means we can't use this guy to calculate frictional force. Now, but we know W cos theta. And remember our fourth derivation earlier that frictional force equals to mu R. Yeah. So we have mu W cos theta. The second question I'll be solving very fast. I just want to see buttress on the point. Now, frictional force equals to mu W cos theta. What is mu here? Now we have 0.4. So we're going to do 0.4 times what is mass? 50 times 10 times cos theta. Remember that to convert mass to weight, we multiply by 10. Now, quickly punch this on your calculator. We have 0.4, do that, times 50, okay, times 10, and times cos 30. Cos 30 is supposed to be 3 over 2. Yeah, but let's just use, okay, since our answer in the question is in decimal point, so let's just leave it in decimal form. We're going to have 173.21 Newton, and that is option B. So you see how simple this question is. You just need, I've just escaped all this point, all these formulas. I'll just come here straight. That's why it's important for you to know the derivation, how to derive it. But in case I forgot in the exam hall, I will derive it from scratch using this diagram. So that way you need to understand this diagram. The diagram is still showing see here, so that we can still make reference to it. Hope you get. So let's go to the next question now. So the next question here says that a body of mass 6 kg, I think it's showing on your screen, rests on an inclined plane. The normal reaction is R and the limiting frictional force is F, as shown in the diagram. Forget about the diagram, we'll get the diagram ourselves. If F is 30 Newton and G equals to 10 meter per second square, then the angle of inclination theta is dash. Now I shall solve this question very fast. Along the inclined plane, we have, let's write out our formula quickly. We have okay, let's first write our parameters, so we just know what to do quickly. 6 kg rest on an inclined plane, so U equals to 0, is not necessarily since it's rest. The normal reaction is arrow and the acceleration. Okay, sorry, let's just use A equals to 0, U is also equal to 0. Okay, the normal reaction is arrow and the normal reaction arrow, and the limiting friction is F. Okay, if F, okay, they gave us F equals to 30 Newton. If F is 30 Newton and G equals to 10 meter per second square, the angle of inclination is this. We already know that we don't have arrow here now, so it means what formula are we going to be using? Very simple. Come back to our stuff. So F equals to W sin theta. You should know that by now you can derive W anytime, any day. I don't need to even write out even though it's diagram or anything. You see, it's very simple. All you just have to now go now is 30 equals to, what is weight? 6 times 10 times sin theta. And I'm going to solve get my theta rather. So I have 30 equals to 60 sin theta. From there I have sin theta equals to 30 divided by 60. From there I get 30 divided by 60 gives you 1 over 2. Sin theta equals to 1 over 2. Theta equals to the sine inverse of 1 over 2. Sine inverse of 1 over 2 as a mathematics student should be in your head. So we're going to have 30 degrees because sine 30 gives you 0.50, that is half. So you see how simple it was. I didn't waste time for this question because we have wasted a lot of time in this video. So our correct answer is option B. Yeah. So I think from these examples, you see that friction and inclined plane is very, very easy. All you need to know is the body sliding down the plane or is being pulled up the plane. Now let me say this before we call it a day. If a body is pulled up the plane, we are going to introduce a pulling force. If a body is pulled up the plane, we are going to introduce a pulling force. And from there, what happens next? If you introduce a pulling force, it means the body is moving up. It means your frictional force is going to come down. I hope this does not confuse you. So if the body is pulled up an inclined plane, okay, let's quickly just use this place. So if the body is pulled up an inclined plane, we're going to get so it's pulled up an inclined plane. So it means frictional force has to oppose the motion. Yeah. So frictional force is going to be acting downwards. Your W sin theta is also still here. It's always here. Please take note. Always. That's the resolution of weight along the plane. Yeah. That's the magnitude of the weight accelerating the body down the plane. Now, pulling force. Yeah, I said pulling force earlier. So, pulling force, we're using a force. We are pulling the body along the plane, up the plane. But this frictional force is going to now downwards. So it's not something that's confusing. What do you do now? Net force equals to the body is moving up the plane. So you have pulling, always know the direction of the body. Since the body is pulled up, it means it's P minus FR plus W sin theta. Why I put it in brackets, you know that both of them are going to carry a negative sign. Yeah, so we're going to do P minus FR minus W sin theta, and you have gotten your answer. From what we have done so far, you see that calculation to friction is very, very simple. Even the dreaded friction and inclined plane, it's very, very easy. Just know how to resolve the forces in the vertical and the horizontal. So that will be all for today's video. I know you have learned something actually, you have learned something new. Just let me know in the comment section what you have learned. And as I promised at the beginning of this video, I will be giving you an assignment at the end. So just watch the end and tell me your answers in the comment section. I'll be in the comment section to check out every response. I'll be marking your answer and telling you if you are correct. And so just let me know your answer. Just type out your answer in the comment section and we are good to go. Lastly, you know this video is going to be beneficial to your friends taking Jamb, YEC, UTME, or level physics. Please share this video to everyone that needs to see it. And don't forget to like this video, subscribe to this channel, and turn on the notification bell. And in case you want to be a part of unusual science tutorial, Jamb classes, YEC classes, NECO, post-UTME, and what have you, just send a message to the number shown on your screen, and you get more information about unusual science tutorial, because I'm co-founder of unusual science tutorial. This video is also sponsored by unusual science tutorial. So don't forget our slogan as usual: keep reading till you become the book. I remain the one and only Dr. Jamb, and I will see you in the next video.